Assalamu alaikum and welcome to Cambridge Chemistry channel with sarwatahmed. Uh, be sure to like the video and subscribe. It really helps the channel to grow. Today I will explain the second part of the dissociation constant of weak acid. So we have discussed earlier about the Laurie-Bronsted theory that strong acids that strong acid are completely ionized in water, and strong acid has a large tendency to transfer a proton to another molecule and that a strong base is one which with a large affinity for the protons. On the other hand, a weak acid has a small tendency to transfer a proton to another molecules. For example, this is weak acid plus water to forms ethanoate ion plus hydronium ion. So it has a small tendency to transfer a proton to another molecule. So this is the proton that has small tendency because it is hardly ionized, so it has small tendency to transfer this proton to another molecules. A strength of an acid can be measured quantitatively by the degree to which the acid molecules are ionized in the following reactions. We can write down this acid like this is weak acid plus water to form hydronium ion, which is equal to hydrogen ion, and this is A negative. So this is quantitatively, we will discuss quantitative analysis of weak acid. For example, in water, the reaction of HCl hydrochloric acid with water goes to completion. HCl is a strong acid. For example, this is weak strong acid plus water to form hydronium ion. So this is completely ionized in aqueous solution. Cl negative, because hydrochloric acid is a strong acid. And this would all mean that the conjugate base of HCl, which is chloride, is very little tendency. So this is the conjugate base of hydrochloric acid, and this is conjugate acid of water. This is base. So this conjugate base has small tendency to accept proton from this molecule, so that's why we can say that it is completely ionized in water. But in case of weak acid like ethanoic acid plus water to form ethanoate ion. So this is weak acid, this is base, and this is conjugate base, and this is conjugate acid. So acid molecules are only partially ionized. Sorry, this is partially ionized. This is only partially ionized in water, and the following equilibrium is established. The establishment of the equilibrium suggests that the ethanoate ion has a relatively large tendency to accept proton, and like ethanoate ion has a strong tendency to accept proton to form acid, and reaction will shift backward. So applying the equilibrium law, the equilibrium constant of this reaction constant is given by Kc is equal to ethanoate ion to form ethanoic acid and water. We know that the Kc is the ratio of the product to the reactants. Since the concentration of water is effectively constant, the above equation can be written as, since the concentration of water is effectively constant, the above equation can be rewritten as Kc is equal to CH3C ethanoate ion, concentration of ethanoate ion and concentration of hydronium ion over concentration of ethanoic acid. Where Ka acid dissociation constant of weak acid is equal to Kc concentration of water. So Ka is equal to concentration of ethanoate ion over concentration of weak acid. Now Ka is called the acid dissociation constant. Its unit is mole dm inverse cube. So the acid can be defined as the acid dissociation constant is measure of the strength of a weak acid it provides an accurate measure of the extent to which an acid is dissociated. So we can identify the strength of acid by given Ka values. Larger the Ka, stronger the acid is. And lower the Ka, weaker the acid. So there is another term pKa. pKa of weak acid. It is more convenient to express the strength of weak acid in the form of their pKa values. pKa of weak acid is the negative logarithm. So it is more convenient to identify the strength of weak acid in the form of pKa values. pKa is the of weak acid is the negative logarithm of weak acid, of the Ka dissociation constant. So mathematically it can be written as pKa is equal to minus log of Ka. So Ka is higher. If Ka is higher, pKa will be lower, and the acid is strong. And if the Ka is lower, pKa value is higher, the acid is weak. So look at the values of methanoic acid for Ka 1.6 into 10 raised to minus 4 and pK is 3.8, and benzoic acid 6.3 into 10 raised to minus 5 and pKa is 4.2, and similarly ethanoic acid is 1.8 into 10 raised to minus 5 and pKa is 4.74. So lower pKa value is 3.8. It means methanoic acid is a stronger acid than benzoic acid and then ethanoic acid. So larger the pKa, weaker the acid is, and lower the pKa, stronger the acid is. So these are the two values which are reversed.